Hi and Assalamualaikum warahmatullahi wabarakatuh. So good day everyone. I'm Shamsul Huda from Petroleum Geoscience course and currently studying at first year, first semester, taking Fundamental of Geophysics at University Technology Petronas. And I'm currently the student for Sir Hassan Suleimani. And so for today, I will present on seismic exploration technique, a core method in oil and gas, and mining resource evaluation. So this is a part of my course evaluation for the coursework mark on this. Okay, so let's move on to the next slide. Okay, so we move on to the introduction to exploration technique. So basically, the main goal of the exploration is to investigate subsurface for resource evaluation, especially for mining and also oil and gas. Uh, so there are two major geophysical methods are used, which is gravity method and also seismic method. So this gravity method detects density variation, good for identifying large sedimentary basin. But seismic method are more detailed because they are more highly resoluted, and they also use sun wave to map the exact geological layer. So while gravity gives us a broad regional view, seismic gives a zoom in high resolution image that guide where to drill. So basically from that we can drill where we want. Okay, for now, clear, right? Okay, moving on to the next slide, which is the seismic exploration. So the seismic technique work by we need to send the elastic wave or maybe the seismic wave into the earth using source like explosive or vibratory struck. So basically this is from the onshore part. So this wave reflect or refract depends on the surface of the earth, and then when they hit the rock layer, and then we need to record them using geophone or hydrophone. Geophone is for onshore and hydrophone is for offshore. Okay, so this recording are called seismograph. So seismogram, seismogram will be converted into seismograph to be analyzed and to be determined what is actually inside to be drilled by the engineer. Okay, so the way the wave travel tell us a lot about the rock type, fault, and potential reservoir underground, so that we can do it perfectly. Okay, so the next one is the difference between two main environment for seismic survey, which is first thing is onshore and the second thing is offshore. So basically onshore use surface tool like vibrator and geophone, often challenged by terrain and human activity. So basically it means like it will be more difficult in onshore because there are a lot of destruction or difference in the subsurface. Meanwhile offshore, so the vessel will shoot the air gun into the water. So the water will have the wave, and then it will go and reflect, and the hydrophone will pick up the echoes from the knee. So both use 2D and 3D imaging. That is well known for us, right? But more 4D seismic is currently taking over all of this, and then is used to monitor how reservoir change during the production. So offshore tends to give better large scale due to fewer obstruction because in the ocean there are just the creatures that got created, that's all, and no destruction. So that it will have less disturb in the data that have been projected. Okay, so we can see here there are two type of seismic exploration as I explained before, which is the onshore and offshore. So the onshore one is like this. Basically, the vibration will release the wave, and then it will be reflected or reflected on the subsurface, and will go to the receiver. So basically, the data will be collected and uh, interpreted by the geophysics. Okay, same goes to the offshore one, but actually the source is the different, which is we use the air gun. So the air gun will release the wave and then it will be reflected and collected by the vessel, which is the receiver. Okay, next one. Okay, let's move to the seismic data organization. So once the data is collected, it goes through several stages, which is acquisition, editing, and also the processing. So basically, the all three steps is basically this include the filter, the noise, because they are uh we cannot just allow the noise like that, because we want to know what is inside the rock. We don't want to know what is before that. Okay. Um, so and also scaling signal and arranging trace by midpoint. So it will give us more detailed information. And the main software that has been used is Petrol Kingdom. Petrol and Kingdom Suite is used to analyze. So proper data management will ensure the right intervention and easy retrieval in the future. So this is very important before making any drilling decision. Okay, let's see this. So this is the basically the seismic data workflow. So we can see here all the seismic data will be collected, and then it will be have data acquisition, and then processing, and also after that it will be interpreted, and it will be suggested to the engineer and also the driller to be considered. So basically, actually, if there is something wrong, the geophysics will got the blame first. Okay. So next one, the interpretation of seismic data. So basically, interpretation of seismic data means we need to read the reflected wave to map the geological structure. So we look for changes in the amplitude or shape of wave to detect fault or fluid reservoir, because when there is changes in structure, we can see that, oh, this is abnormal, so we cannot do this. Okay, next one is time to depth conversion, so which help us turn signal time into actual depth using velocity model. So, and also some of the advanced method like AVO and also seismic inversion allow us to estimate rock properties such as porosity, which is the main one, and also the fluid saturation more accurately. Okay, so we can see here there are three type of seismic interpretation. So basically the back this is the example of seismic interpretation, which is normal, and then we can see there is fault here. So basically this is the normal one, and then there are another two type, which is this is the AVO interpretation, and also this is the time depth conversion. So basically from this is the main three common, and all geologists in the world will use these three, so that it will be consistent all around the world. Okay, so moving on to the case study. So we take case study in Baram Delta, which is in Sarawak. So it's one of the Southeast Asia most richest hydrocarbon zone, because Malaysia is as well as known as one of the biggest producer of the oil and gas, is other than the Middle East, right? Okay, so the main company that use that do the seismic survey here is Petronas and Shell. Petronas and Shell. So the survey showed amplitude anomalies, so which is the bright spot that indicate gas presence. So what make when they found there is some like, oh, here is gas, oh, here is oil. So what they will do, the discovery and development will be more bigger, such as here they have like F23 and E11 gas field. So the seismic technique play a direct role in finding this reserve efficiently. Okay. So this is the example of interpretation in Baram Delta, which have been found in Petronas report in 1998, I guess. So this is, we can see that there is fall and also there is fluid seep. So basically the fluid seep, we can say that there are fluid inside that can probably be oil and gas. So there when we need to do the first well logging. So when we do the well logging, we can determine which type of sediment, which type of rock is there, and what is the possible fluid to be stored under the rock. Okay. Okay, so next, everything will have also advantages and also disadvantages, right? So for advantages for seismic method, so it give us high resolution subsurface imaging, and also it can be used in both onshore and offshore, and we can identify the reservoir and structure more detail, and also support mapping and stratigraphy, and also integrate with other database, because it also integrate because data need to be considered, because if the data is also only for one type of method, it will be difficult for other type. especially in the place where there is limited to one. So this is the disadvantages as well. So the first one is high cost, which is equipment and processing. The second one is environmental impact, because it will require a lot of drilling and also a lot of stuff, right? And then third one is require very skilled workforce, because when we have the skilled workforce, it will be more easier to us. And then 3D and 4D will take not like 10 to 15 minutes. It will take very, very, very long time. It's like 5 to 6 hours. That is minimum, right? That is the bare minimum. So it will take a long time. So when there is less time, when there is more time to get a small data, so it will be very time consuming process there. Okay, and the last one is there are some issue to access in urban areas, such as where the building are full. So maybe they found like, oh, here is possibly some oil and gas, but how to drill, because there are a lot of buildings, so it will be very difficult for them. Okay, so next, moving on to limitation and consideration. So the limitation, ineffective in complex geology, because such as salt dome, because when the geology is too complex, it will very difficult to reflection to occur smoothly, and it will affect. And then the next one is very costly for small project, because um, for small project it is very unnecessary, because we can use other method as well. Okay, and then wave distortion from overburden, because there are possibility of the wave to become changed and also to become in not orderly manner. And also the urban logistic difficult, as I said in the previous slide, and also dense sensor array. So basically it require a high value of the sensor. Okay, so what can be done to avoid this is that um so maybe environmental regulation can be done by the government to allow more survey, and also more uh, process of finding this subsurface, and also the some of alternative technique that we can use, such as passive method, which this didn't require any energy, like gravity method. Okay, so almost at the end. So in conclusion, seismic method have transformed how we understand the Earth subsurface. So 3D and 4D seismic especially have helped us reduce exploration risks. So moving forward, the industry should adopt AI-based analysis and full waveform inversion to improve the accuracy. It's not mean like human don't need to do this anymore, but human can be like the one to supervise, and then to make sure there is no fault that been done by AI, because AI is very, very important in the industry revolution 5.0 that will be coming soon in Malaysia. So also collaboration between industry and university is very important, and we should also reduce environmental impact, and also we need to train more skilled local geoscientists, such as what UTP has been done with the collaboration with Petronas, to provide more and more petroleum geoscientists in Malaysia, because in Southeast Asia only UTP provide petroleum geoscience course. Okay, so this is some of the reference that I have made. So basically, this reference not the real book, is the simplified version of the book that I found in the internet based on my research. And also, there are some Petronas report in 1999, uh, which there where I found the case study for Baram Delta. So from this, what I can learn is that I learn a lot on how to find the information. Basically, this detail is very easy for us to understand actually, but when moving forward, we do some research, and then we like, oh, this is what Sir explained in the class before, like that. So they will be very helpful. Okay, so thank you, sir, for this semester. I hope you can have a good day, and we can get a good mark. So I wish you all the best for all of my classmates as well. And thank you, sir. See you soon in during the examination. Thank you, and assalamualaikum warahmatullahi wabarakatuh.